Hi, everybody. This is my example. I got a phone call. Let me pause it. All right, everybody. This is example problems for chapter 8. And I'm going to skip chapter 8.1. It's a conceptual example. I will leave that to your pleasure to solve on your own time. It refers back to a problem in 6.5. So I'm going to leave that up to you. And we're going to start with 8.2. Which is a ball hits a wall. Oops. All right. It states you throw a ball with a mass 0.40 kg against a brick wall. It is moving horizontally to the left at 3 meters per second. So the initial equals 3.0 meters per second. That will be in the negative direction. We'll just call that a negative. When it hits the wall, it rebounds horizontally to the right at 20 meters per second. So BF, if you will, equals, this is 30, my bad. And this is going to be 20.0 meters per second. And this is going to be a positive since it's going in a different direction. A, find the impulse of the net force on the ball during its collision with a wall. B, if the ball is in contact with the wall for 0.10 seconds, so delta T equals 0.010 seconds. Find the average horizontal force the wall exerts on the ball during the impact. Okay, so using my velocities, I'm going to calculate my initial momentums and final momentum. So P1 equals 0.40 kg times a negative 30 meters per second. And my initial momentum is negative 12 kilograms meters per second. And my P2 equals, again, the 0.40 kg times a positive 20 meters per second. And that's going to equal to 8 kilograms meters over seconds. All right, we know that the impulse, J, equals the change in momentum, P2 minus P1. And so we have P2 is 8 kilograms minus a negative 12 kgs, meters per second, meters per second. And we get the change in momentum to equal to 20 newtons times seconds. So the collision time, delta T, is equal to 0.010 seconds. So we know that F delta T equals J. So J divided by delta T equals 20 newtons times seconds divided by 0.01 seconds. And then we have that to equal 2,000 newtons. And that is 8.2. Okay, we're doing example 8.3, which is kicking a soccer ball. And it says, a soccer ball has a mass of 0.40 kilograms. It is moving initially to the left at 20 meters per second. So initially it has a velocity of negative 20.0 meters per second. After kicking, it is moving at 45 degrees upward and to the right with a speed of 30 meters per second. So after kicking, it's doing something like this. 45, and this is 30 meters per second. Find the impulse of the net force and the average net force, assuming a collision time of delta t equals 0.010 seconds. Okay, finding the initial and final components in the x direction. V sub x initial is going to equal to that negative 20 meters per second. Wow. And V sub x final is going to be equal to 30 meters per second cos 45. V sub y final is going to equal V sub y final is going to equal the same value, magnitude, 30 meters per second sine 45. And V sub y initial is going to be 0. It was just rolling on the ground. That's 21.2 meters per second. This is 21.2 meters per second. And this is 21.2. All right, let's see. Now I'm going to find the components, the impulse components. So the impulse is defined as the change in momentum. So 0.40 kg times, let's do x first, 21.2 meters per second minus a negative 20.0 meters per second. And that's going to give me 16 kilograms meters times second. Meters over second. And so the impulse in the y is going to be 0.40 kg. I don't know about this whiteboard here. Times 21.2 meter per second minus 0. And that's going to give me 8.5 kilograms times meters per second. All right, let me pause this and clear it. So we're working with those two values. Let's get the J equals F delta T. So F is going to equal to J divided by delta T. So F sub X equals 16.5 kilograms meters over seconds divided by 0.010 seconds. And F of Y is going to be equal to 8.5 kilograms meters over seconds divided by 0.010 seconds. And so we have, let's see, 16.50 newtons here. 1650 newtons. And here we have 850 newtons. And so we are going to get the resultant F average going to equal the square root of both of those squared. Was 850 newtons squared. And I'm going to get 1.9. 1.9 times 10 to the third newtons. And then I'm going to take the tan inverse y over x, 850 newtons, divided by 1650 newtons. And I'm going to get 27 degrees. And that is 8.3. Okay, and this is a 8.4 recoil of a rifle. Boy, this is strange whiteboard program. Recoil of a rifle. And so it says a marksman holds a rifle mass 3.00 kilograms. Loosely, so it can recoil freely. Fires a bullet of mass 5 grams. So bullet is, let's go ahead and convert that. 5 grams would be 0.512, okay, 0.005 kg. Horizontally with a velocity relative to ground of 300 meters per second. So V initial equals 300 meters per second. What is the second velocity? The recoil velocity of the rifle. What are the final momentum and kinetic energies of the bullet in the rifle? All right, we're going to use conservation momentum, and we have the momentum before equals the momentum afterwards. So before they have zero combined momentum, they're just at rest. So that's going to be equal to, I guess, bullet is going in the right direction. So 0.005 kg times 300 meters per second plus 3 kg times RV, recoil velocity, if you will. So this is going to be 0.005 kg times 300 meters per second divided by 3 kg. And that'd be, yeah, you're going to put a negative here because we put this to the other side and then divide it equals RV. And my recoil velocity is going to be negative 0.500 meters per second. So RV is going to be equal to negative 0.500 meters per second. All right, that's that part. Okay, now I'm asked to find the final momentum and kinetic energy. Okay, so we have the momentum of the bullet is simply going to be, momentum of bullet is going to be 0.005 kg times 300 meters per second. And that gives me 1.5 kg times meters per second. And the momentum of the, oh, see, I'm going to use P. The momentum of the rifle is going to be the negative of that, right? Negative 1.5 kg meters over second. And the kinetic energy. Okay, so this is going to be of the of the bullet is going to be 1/2 mv squared. So we've got 1/2 times 0.005 kg times 300 meters per second quantity squared. And that's going to give me, let's see, 225 joules. And similarly for the 1/2 mv squared for the rifle, we're going to have 1/2 times 3 kilograms, 3.00 kg, times negative 0.500 meters per second quantity squared. And that's going to give me 0.375 joules. 0.375 joules. All right, so momentum is conserved. Kinetic energy, not necessarily so. All right, this is 8.5. It's a collision along a straight line. And it says two gliders with different masses move towards each other on a frictionless air track. After they collide, glider B has a final velocity of VFB, we'll do with that, 2 meters per second, positive 2 meters per second. What is the final velocity of glider A? How do the change in momentum and velocity compare? So, yeah, we need more information, but we know from the picture over here, let's see, velocity initial of A equals 2.0 meters per second, and the mass is 0.50 kilograms. Mass of A equals 0.50 kg, and velocity of B initial, V initial of B is negative 2.0 meters per second, and the mass of B is going to be 0.30 kg, 0.30 kg. This is a 3 there. All right, so P before equals P after. So let's see, we have 2.0 meters per second times 0.50 kg plus a negative 2.0 meters per second times 0.30 kg, and that's going to equal to, we've got velocity B at 2.0 meters per second, and B is 0.30 kg plus velocity final of A, which we're trying, times the mass of A, which is 0.50 kg. And the answer here, let's see, is going to be 0.4 kilograms per meter. So the velocity final of A, if you do the math, it's at 0.4. Oh wait, that's the momentum. What am I looking for? Yeah. Velocity, right? What is the final velocity of glider A? Glider A, I got that final momentum. Final velocity. Negative 0.40 meters per second. Yeah. There you go. and that was 8.5. All right, this is 8.6, collision in a horizontal plane. States figure 8.14 shows two paddling robots on a frictionless surface. Robot A with mass of 20 kilograms, MA equals 20 kg. Initially moves at 2 meters per second parallel to the x-axis. So it's got a V initial A equals 2.0 meters per second, parallel to the x-axis. It collides with robot B, so which has a mass of 12 kilograms. And is initially at rest. So V initial of B equals 0 meters per second. After collision, robot A moves at 1.0 meters per second in a direction that makes an angle alpha 30 degrees with the initial direction. So